project is Understanding Animal Communication Using Machine Learning.
Okay.
In the quest to improve the interaction between humans and animals, we decided we wanted to directly communicate with them.
Okay.
We wanted to translate their forms of communication into our language.
In a review of over 30 websites, books, and experts, we learned that animals communicate through many different modalities, such as chemical signals in fireflies, hormones, acoustics, visuals, electric signals in aquatic animals, and even poop. However, humans are usually unable to pick up on these types of communications. Our solution will allow us to combine these modalities to better understand the animals.
Understanding animal communications can help humans better distinguish the state of the animal, whether they're sick, scared, sad, or playful. This improved communication can be used on a one-to-one basis with a pet or farm animal to provide more humane treatment and increase productivity of commercially used animals, or to make decisions on the welfare of endangered species.
Our solution is to record animal communications and use machine learning to interpret their meaning. Machine learning teaches a computer from its previous experience. Some examples of machine learning are in voice recognition tools such as Hey Siri or OK Google, or facial recognition such as the one that's used in Facebook and Google Photos. In a program such as OK Google, the program learns to recognize your unique and individual voice so that it can perform more accurately for you. One rule for any machine learning program is that the more data you collect, the more accurate your algorithm becomes. To learn more about machine learning, we spoke with expert Steve Chen, a PhD candidate at the Penn Robotics Lab.
Our expert advised that we start our project by recording human sounds that are happy and sad, and applying machine learning algorithm to them. The first set of sounds is called a training set. After the algorithm learns to differentiate between happy and sad sounds, we test a new human sound in the program to see if the computer can identify the emotion. This is known as supervised learning. In our next phase, we will do the same with animal sounds instead of human sounds. After that, we will use machine learning to determine new clusters of similar animal sounds and other animals and try to identify them. For example, we may discover a cluster of animal sounds or modalities that identify hunger.
One option we had for data collection is to make a pet collar that can record data. Requirements of the collar include a microphone, clock, near-field communication chips for monitoring proximity to a food bowl or litter box, and heart rate. The collar would record this data, then transmit it to the cloud using Bluetooth, which is cheaper and uses less power than Wi-Fi. To power the collar, there would be a button cell battery that lasts about 2 years. The collar would not determine the animal's emotion, but it would collect data so that the machine learning algorithm can. Our cost goal is to retail the collar for under $75, and our target price for cost is $25 in mass production. We had Alan Stein, an MD, PhD, who has expertise in medical device development, review these plans for a collar.
We reviewed at least half a dozen other solutions, including Jagger and Lewis's Smart Dog Collar, Pet Paste, No More Woof, which were helpful in giving us ideas for data collection and design. We also identified a patent attorney who will help us. None of the existing solutions were quite like ours.
This is the roadmap of our project. First, under investigation, we are researching animal communication and machine learning. We've spoken to 2 engineers who are experts on machine learning and designing electrical devices. We've spoken to 1 general animal expert, and we're scheduled to meet with an animal communication expert on Monday.
During the design process, we are learning Python and designing a machine learning program. We are also developing criteria for a collar that can record sound and other types of data and metadata.
In the testing phase, we will first run our algorithm with happy and sad voices. Then we will gather some animal sounds to test our algorithm. Hardware testing will occur later after we create a prototype of our collar. We will test our collar on a few animals to see if we have to make any design changes.
In the data collection phase, we will distribute our data collecting collar to thousands of animals to gather samples. The more data we collect, the better we will understand them.
So far, we've shared this idea with about a dozen experts and met with 3 of them. Our final product can be implemented in many forms. The most likely first application will be a translator that can take an input of animal sounds and output the emotion the animal is feeling.
Alright guys, final thoughts.
If you've seen the movie Up, the dog wears a collar that translates his language to human language. And if you did see that movie, you probably thought that a collar like that was impossible, but now it doesn't really seem that far off at all.
Okay, wow, that's
Perfect timing.
You're done.
So last software we had like 2 lines.
Yeah. It's good timing. Okay, so how'd you come up with this?
Okay, so a while ago, as soon as we found out that the project was Animal Allies, we started thinking about ideas, and everyone sort of brought in like a PowerPoint. This is way before we knew the actual project, but we figured it had something to do with animal human, right? So I brought in a project, and I was like, hey guys, we should probably learn on like animal communication. And they were like, okay, that's cool. How are you gonna do that?
Alright.
So then later I had the idea to use machine learning, and Mia had the idea to use a collar, and we all put our teams together.
So how is your idea for a prototype going to be different than what's currently on the market? I really enjoy the idea that you actually explained how Bluetooth is different from wireless and why one could be a thing, because that's actually trips up a lot of people, which is, I'm sure, what we do.
Our prototype is
Yep.
going to be different than pet paste because our sound, we record sound and we tell you we are going to tell you what your pet is saying or any other. Not
Or
just,
a pretty broad majority of like
Yeah.
what it is that they're probably trying to do. Okay. Alright.
If I may,
Absolutely.
sound for us actually is the first thing we thought about. So
Okay.
before we thought about heart rate or respiration or anything, we were thinking about sound specifically.
Okay.
We were trying to lean towards vocal animals, but we decided that it would be better to just use other modalities too and just get
Combine.
everything together.
Okay. Alright.
So one more thing is, so machine learning enables us to sample thousands and thousands of animals. And say we're doing, so say we want to figure out dolphin communication, right?
Okay.
We haven't spoken to an animal communication expert yet, so we need to figure out what animal. But for now, dolphins. We sample thousands of dolphins, and we learn really deeply from the thousands of sounds. So, and hopefully we can have, say, an app or something, or a translator that can actually record animal sound and translate into the emotion, or hopefully even more specific than that, what the animal's feeling.
Okay.
And what would you like to share?
So we all have pets, and about how we were saying earlier that once we have our prototype built, we're going to make a few more and then test it on a few animals, and we all have pets, so we might test it on them instead of other people's animals to see if we have to change any designs and then put it on the market. And my mom is actually the patent attorney.
It's always nice to go to a parent.
Yeah, it is.
Great.
I was curious, I'm a member of Paws for People. Have you heard of this type of organization?
Imagine it's like repeated or something.
Yeah, you take your dogs and they train them, and you could reach out to that type of grouping.
I would love to do that.
Okay.
Yeah, that's one.
Great, thank you.
So you've talked with a couple of people at Penn and all that stuff. Who else have you shared it with? Obviously, the patent attorneys. Free labor. Who else you got?
We are actually trying to get my vet right now,
Okay.
and like he has been with us for like years.
Okay. Good.
Awesome.
We also talked to Alan Stein.
MD, PhD.
Yeah.
in-
Yeah, so he just gave us like on the information of what types of like modalities we should use. What
For a collar.
yeah, for a collar.
All right.
We're also we're also scheduled to meet with many. We reached out to many animal communication experts. For example, we also reached out to the Philadelphia Aquarium, I believe, and many experts in the Penn Vet Behavior Center. Only a few responded back, and we're meeting with one on Monday to discuss which animal we should use and how we really identify whether an animal is happy or sad,
Okay.
so we can teach our algorithm.
sometimes we get our sounds from acoustics.org,
Okay.
and we researched about tags for dolphins when we were thinking about
Okay.
choosing an animal.
Yeah.
I was researching tags, and then we searched the Max Planck's Institute.
It's just one of our research. Yeah, we researched a lot of online options, and it's in the packet, I believe. And that's not even.
Oh, I'm sure it's not.
Yeah.
Who? Oh, this question. Oh. Oh, well, I don't know.
That's okay.
And just a question, will you be working on the motion or hunger first? What are you thinking at this point? I know you offered them out there, but where do you think to begin?
Well, we're gonna start with very simple, happy and sad. We're beginning with human voices. We've recorded some of our own, and we have started. My dad and I have started actually writing a Python program
No, that's another one. Okay.
to actually do it.
Okay. It's very interesting. Seems really great, and unfortunately, we are gonna have
That
to
was
leave
all
there.
there.
Okay.
Thank you so much.
Thank you.